Hi, I'm Ann of All Trades, and today I hope to demystify the sharpening process so that you can use whatever method you'd like to achieve a sharp blade. There's so many options out there: scary sharp, oil stones, waterstone sharpens, diamond plates, plate glass, sandpaper, strops, jigs and fixtures, all kinds of things that people have tried to invent to make the sharpening process easier. For a blade to be truly sharp, you need to have a perfect intersection point between the bevel and the back of the blade. And really, if you're going to take one piece of advice away from this whole thing, it's this: pick one method, learn it well, and stick with it. A lot of people just have their grandpa's old tools. In fact, this is my grandpa's old tool. I remember using this at his workbench when I was a kid, and this is probably one of my most prized possessions as a result. There's one quick improvement that you can make to any old tool, and that's to replace the blade. A lot of these post-war era blades are just super thin and flimsy, and not only does that make them not work super great because it causes them to chatter along the wood, but it also is just such a thin surface that it's really difficult to get that to register on your sharpening stone for effective sharpening regardless. The difference in thickness between this blade and this blade, as you can see, is pretty significant. Okay, let's sharpen a blade. One thing I like about honing plates is that they're a little bit cheaper, but they can be a little trickier to use. One thing I love about oil stones is that you can use oil to lubricate the stone, and therefore you're not getting your blade, which easily rusts, wet. Diamond plates are my favorite thing to recommend for beginner woodworkers because they are guaranteed to come and remain flat. I personally like to use waterstones because it's what I learned how to sharpen on. Also, I had made this initial investment and I really want to stick to it. The negative of waterstones is that you have to be extremely fastidious about keeping them flat. And so not only do you have to have two different grits of waterstones, I like to have a 1000 and an 8000 grit. You also need to have a flattening plate to keep them flat, because as you're sharpening your blades on them, they will dish, and that will cause them to lose flatness and therefore lose the ability to effectively sharpen your tools. A lot of people don't believe me about the quick dishing of a stone. So they say, well, how do you know if your stone is actually flat? Well, this is a fantastic way to just make sure that you're removing material from the entire stone as you're flattening it. Just make a pencil line grid along the stone. So as you can see, I still didn't have it quite flat even just a moment ago. I'm going to pull out my 1000 grit waterstone, and I will first freehand sharpen a blade. This is one of my grandpa's old tools. I have put what's called a hollow grind on this. So a hollow grind is done on the grinder, and the wheels are spinning this way, and you put the blade up to the grinder, and then therefore the round wheel is contacting on 2 points, the tip of the bevel and the back of the bevel, leaving a little hollow there. Then when you go to put this on your stone, you have two registering points on the stone. We're going to take this hollow ground blade, we're going to lay it down on the stone this way, and we're going to raise it up until you see that vacuum seal. Do you see where that vacuum seal happens with the water and the hollow grind there? So now I want to make sure that I have my body locked into a position that's comfortable for me. I want my elbows tucked in. I want to have equal pressure both on the front and the back of the blade here. I'm using the back of my hand here to support the blade. And I'm going to lock my elbows and pull. And now look at the way I've got my body so that I can rock back and forth and not move my wrists. I'm not pivoting the blade. You can see that the blade is rubbing here and here on the stone. And we will continue this process until we've made a burr across the whole edge of the plane. For most beginner woodworkers, I actually recommend that you do buy a jig. If you're really on a budget, these things are $8. This is an Eclipse jig. I know a bunch of different companies made them, and there are actually a few ways that you can modify this tool so that it works the way that it should. It doesn't unfortunately come out of the box working the way that it should, but for $8, I really don't know how you could expect that it would. Veritas also has this design. This is a fantastic little jig. However, I've found it so complex that a lot of beginners really struggle to use it. Recently, Lee Nielsen made a improved version of the Eclipse design, because I find this tool to be such a huge asset in teaching beginners how to sharpen and have repeatable results. This is the jig that I recommend. I sharpened freehand full-time for about 4 years, and I knew how to get my tools sharp. The thing that I did not know how to do is have repeatable results and scientific calculation of what was going on with my tool. With a honing guide like this, I can set the projection from the guide the exact same amount every single time and get the exact same angle, the exact same cutting angle every single time I put my blade back in my tool, which for me is a huge asset. I use mostly local hardwoods, so that's walnut, maple, some hickory, some Douglas fir. All of those woods behave pretty well with my low angle jack plane and a 35-degree micro bevel. So I actually just double-sided taped the projection distance to maintain a 35-degree micro bevel on all this stuff. If I end up with a piece of curly maple that just will not cooperate, then I can change the projection angle of this and see what angle is going to fix that curly maple and which angle is going to actually be repeatable in that sense. But it's not a constant, well, I sharpened it and it worked really well this time, but then the next time I freehand sharpened it, I accidentally raised it a degree or lowered it a degree and caused myself a giant guessing game as to what it was that caused me to have success on my thing. It has the wheel in the center of the blade so that you can balance on both sides here. And so you'll notice too that I'm only pulling. When you're pulling, you have a whole lot more control. If you're going back and forth like this, there's a chance that you're building up a slurry in front of the blade of abrasive materials. Every once in a while, I'll flip the stone over so that I know that I'm wearing it evenly. For a blade to be truly sharp, you need to have a perfect intersection point between the bevel and the back of the blade. That intersection point is made a whole lot easier if you have a perfectly flat back. What you're doing when you are sharpening the bevel of your blade is you are abrading the surface, you're removing material, but you're also moving material, and you're moving that material up to the back of the blade, forming what's called a burr. Now, a burr is actually a cutting edge in and of itself. You create a burr to make your scrapers work properly. However, a burr is a very jagged edge, and what we want to do when we're sharpening our plane blades, which is why we hone the bevel and then we polish the back and then we hone the bevel again and polish the back again, is because we're always moving that burr back and forth and trying to get as refined of an edge as possible. And so that's why we also use different grits of stones, is because we're actually just trying to make that burr smaller and smaller, move it back and forth until it finally breaks away and we're left with a nice, clean, polished edge. Now, how clean or how polished of an edge do we need? That's actually subject to a whole slew of debate that I'm not going to get into. But I will say, to protect your budget, that you really only need a more coarse abrasive stone and a fine abrasive stone, and whatever you define that as is totally fine. I define that as a 1,000 grit and an 8,000 grit water stone, and I don't use any of the stones in between, because this is where 1,000 and 8,000 is very different than 80 grit sandpaper and 400 grit sandpaper. With the difference in the molecular structure of the 1,000 grit stone and the 8,000 grit stone, I think is small enough that you can easily remove the scratch pattern from the 1,000 grit stone with the 8,000 grit stone and maybe just a few more seconds of time spent, as opposed to the extra financial investment in getting a 2,000, 4,000, 6,000 grit intermediate stone and keeping those flat and taken care of as well. Your fingers can feel an astronomically small burr if you train them to look for what they're trying to feel. You need to make sure that you are raising an equal burr across the whole edge of the plane blade every time, because if you only have a burr over here, then you're only sharpening the plane over here. So once I have a full burr across that whole edge, I'm good to go on that stone. I will put it back in the water to soak there. And then I'm gonna grab my 8,000 grit stone. So again, that was a 1,000 that we were just on, and now I'm moving to an 8,000 grit. Now, as I'm putting it on the 8,000 grit stone, I'm polishing the edge. And I mean, the reason that 20 and 60,000 grit stones exist is because people will understand that the more you polish and refine your blade edge, the longer edge retention you'll have. Because basically, if we were to look at this under a microscope, we would see actually all kinds of tiny little mini serrations along the blade. As we're polishing it, we're making those serrations smaller and smaller and smaller. So why do I stop at 8,000 grit instead of going all the way to 60,000 grit? Because there actually are 60,000 grit stones for sale. And that's, again, just the law of diminishing returns. I really don't want to have to maintain or purchase, to be honest, 15 different stones to be able to get to an edge that wears nicely. And I think if you go from 1,000 to 10,000, 1,000 to 8,000, you're going to be golden. If you have a brand new tool, and a tool that you probably paid a fairly premium price for, like a Lee Nielsen or a Veritas tool, it's very likely that the back of the blade has already been perfectly machined flat. That said, there can always be errors in machining, or if you've got a vintage tool that has rust and pitting and cast iron moves just like wood does, so it could have warped or changed. I never like to assume that my plane blades are flat. Under the assumption that your plane blade is not perfectly flat, David Charlesworth came up with this fantastic technique where you use a little ruler. In fact, it's called the ruler trick, to create a very slight micro bevel on the back of the blade. What is fantastic is that it lifts the back of the blade up ever so slightly, so that if this blade is not completely flat, at least the leading edge of the blade is completely flat against the stone, which will allow me to remove the burr from that entire area. So we just use water on that tool to sharpen it. So now we want to make sure that we not only have dried off all the water, but we want to give it a little bit of an oiling really quick. Now, again, be careful, don't rub this way because you'll cut your hand off. This is just a dust cloth, a microfiber dust cloth. I sprayed some jojoba oil on it, and jojoba oil is only special in that it doesn't have very many static properties. Mineral oil tends to be a little bit static, so it actually attracts dust to it, which dust collects moisture, and then moisture rusts your tools. So if you're using all your tools all the time, it really doesn't matter what you oil them with. But if you sometimes go for months at a time without using your tools, then you really want to make sure you're oiling them on a regular basis, especially when you're getting them wet. I just brushed out all of the dust from this tool. I'm oiling the surface that's going to mate with the blade. I'm going to set it down and just very carefully set the blade down into the mouth of the plane, making sure not to scratch it or anything else. With this tool, once we have a nice sharp blade, we want to put the chip breaker back on and actually attach it kind of out here with it off the blade, because I don't want to scratch the blade with the chip breaker. I don't want to do this. What I want to do is get that little screw started in there and then back it off so that I can put the chip breaker back on from over here. Oopsie. And then as far as projection from this goes, you want the chip breaker to be about the same distance from the edge of the tool as the thickness of the shaving you want to take. But remember that these older tools are very thin, and so when you start to tighten that down, it's going to want to creep forward. So I will often put that chip breaker a little bit further back to start. Very carefully place it down in the bottom of the tool without touching any of the other metal components there. Put on the lever cap here. So now, once you've put your blade back into your tool, you need to set it up so that it's ready to take a shaving. Grab a scrap of material off of the floor of your shop and keep it, because we're gonna actually use it for me to show you a little quick trick. Travel the blade all the way back so that you can't see it projecting out here anymore. And now you're going to scooch it forward till you can just see the shadow of the blade projecting. And then at this point, because I'm reflecting off of a lighter surface, I can actually see the shadow of the blade when it starts to come out. So I can see right here, it's a little high on this side. So I'm gonna adjust it. And at this point, I'm gonna use this little scrappy to see. This is fantastic because you can tell not only if the plane is taking like the same width shaving, because you can do it by feel here. I can feel actually that now the shaving's a little heavy on this side. You can gauge the thickness of the shaving, make sure it's the shaving you want to take with this. But then you can also make sure that the depth of cut is where you want it as well. If it's too hard for me to push this across like this 1/4 of an inch of the blade, then how hard do you think it's going to be to push the plane when you're using the entire thickness of the blade there? Once you approach your piece of wood, you want to basically create a tripod of strength. Handedness becomes a very interesting issue when you're talking about hand planing, so I'd actually encourage you to try it both ways. But basically, whatever hand is on the back part of your plane, you want the opposite foot to be facing forward, and you're basically making yourself a tripod so that you can actually use your core to guide and move the plane. You want to actually be flexing your abs while you're using the plane, because otherwise, if you're just bending over and pushing it with your arm strength and your back strength all the time, you are gonna, once again, be in for a world of hurt. So we're going to use that same method on this other tool, even though it looks slightly different. And I'm actually going to use my hammer on this tool as well. All of these tools have adjusters here, lateral adjusters, but I actually don't like using them because look at how much play there is in that. And then you're off to the races. So thank you so much for taking the time to watch this video. I really hope that it helps give you a little bit of confidence when it comes to sharpening and setting up your tools, because using hand tools should be fun, and the best way to make it fun is to start out with a sharp tool that's set up properly.